Okay, today's video is going to be about colour detection.
Okay, the first thing is to understand how the colour sensor works. The colour sensor on the left there is set in reflected light intensity, and the colour sensor on the right there is set in colour mode. Now, in reflected light intensity, it just simply sends out one beam of light and measures how much of that light's been reflected back to know the gauge. When we're in colour mode, instead of sending out one beam of light, it actually sends out three beams of light. It sends out a red one, then it sends out a blue one, then it sends out a green one, and it detects how much of each one of those have been sent back. And you can see those circles there, the red circle, the green circle, and the blue circle. So it doesn't read colour, it reads how much of each of those three colours is sent back. And depending how much of each of those three colours is sent back, it does a calculation and tries to work out what the actual colour is. Okay, first of all, to be able to read the red, green, blue reflected light from the sensor, the only way to do that within the Ev3 language is with the custom block created by David Gilday as a part of his Rubik's Cube solving robot called MindCuber. You'll have to go to his website and download that block in order to be able to do accurate color detection. So first of all, before we can start writing a program to detect color, we need to write a program that reads the color so we know what we're detecting. So what we're going to do is we're going to write this little program here. It's basically just got the custom block that reads the raw RGB reflected light. Then it has three display blocks to display those three pieces of information. Then it just waits half a second, so it gives a bit of a chance for us to read it. Then it loops around and does it all over again. So we just have an infinite loop, the David Gilday's custom RGB sensor block. Then we have a screen block, and the screen block we're going to set into display text in pixels. We're going to go up to the top corner there, and we're going to select it to display via wire, and we're going to pull a wire out of the very first block and put in there. And then the second block we're going to set to display text in signals in pixels, and the same thing, we're going to set it to a wire, and we're going to pull a wire out of the second one and put it into it. But we're also going to switch this clear screen to negative, because we don't want it clearing the screen after it's written the first one. It just wants to be cleared right at the beginning. Then we pull out the third block and we do the same thing, set it to text in pixels and to be displayed via a wire. You'll pull the wire out of the last one and plug them in there, and also make sure that you're not clearing the screen or you won't see the first two ones. You also have to change the position of where we're writing to the screen so it doesn't write the three numbers on top of themselves. So in the first one, I'm going to have the Y position at 0 at the top of the screen. The second one, I'm going to have the Y position at 40, so it's about halfway down the screen. And the third one, I'm going to have it Y position at 80, so it's near the bottom of the screen. And here we have it in action. I've got two sensors on the front, but the left one that's plugged into port 1's the one we're using. We've got some white here, some green there, some black line, and even a bit of a purple strip. So we will run our program. You can see on the screen, spits out three numbers. Now, because we're sitting on white, the three numbers are quite high because it's reflecting a lot of red, a lot of green, and a lot of blue. We put him over the top of the green square over there. You'll find the red's not all that high, 65. The green's up at 143, and the blue's down at 73. We'll put him over the black. You'll find that all three numbers are quite small because the black doesn't reflect a lot. Put him over this bit of purple paper I have here. We end up with 95, 23, 56. So that's the amount of red, green and blue. If we want to identify a colour, we need to know what raw values it brings back. So say I am looking for this purple strip and I want to be able to bring purple. I need to know 95, 22, 57 and look for that. Okay, now we can actually look at trying to write some code to detect some colours. We will do that by seeing if the RGB data coming out of the colour sensor is giving very similar numbers to what it was on the screen when we were holding it over a certain colour. If it is, it's very similar to that color we're holding it over. So in order to do that, we're going to use these in range blocks, and they work by the input value you put into them. If they're within this range, then it returns true. If they're not within the range, it turns false. So what we're going to do is we're going to put 3 of them in a row. I'm going to put the output of the red into the first one, the output of the green into the second one, and the output of the blue within the third one. Now, if at the moment the range is just set from 25 to 75 on all 3 of them. So if the red is within that range, 25 to 75, it will return true. If the green's within that range, it'll turn true, and so on. Later on, we will adjust those ranges to be for the colors we're looking for, but for the moment we'll just leave them like that. Now what happens is the color's only going to be correct if all 3 are true. If one's true and the other 2 are false, it's not the color we're looking for. We want the red to be true, the green to be true, the blue to be true. So to do that, we'll put these 2 logic operators at the end to add it all up. And you'll put the output of the very first block into the A of the first logic block, the output of the second one into the B, and make sure it's switched to AND. So it will only return true if both A and B are true. And we'll put that into the second block along with the output from the third in-range block. So now the output of the second logic block will only be true if it's within range of all 3 components. So because color detection is a very common process you do quite often, the best thing to do now is to save it in a My Blocks, i.e. create your own custom block, and that way you can use this bit of code anywhere you want. You can even export it into other programs. So to do that, we need to highlight all that code and go up to the Tools menu in the top left corner and click on My Block Builder, and you'll come up with this page. Then we have to name it. I've named mine color underscore detection. It's best if we give it a bit of a description. I said detects if a color is within a range. You'll need to pick the icon you want. I just picked a little color sensor icon. Then we need to press this plus button to push out the parameters that we're going to give it and what we're going to get back. And you'll need keep pushing it till you have 7 parameters to put in the minimum maximum values for your RGB, and also for it to return whether it was within range or not. Right, and you'll need to go through each one of those and set them up. You'll click on him and you'll come down to parameter setup. You'll give it a name. The first one will be red min, and the next one will be red max. The next one will be green min. The next one will be green max. The next one will be blue min. The next one will be blue max, and the very last one will be logic output, like you see on the screen here where I've got the last one in. Right, you'll have to set your parameter type. Your first 6 are going to be input values, and they're going to be numbers. The very last one is going to be an output, and it's going to be a logic. Right, then you can click across under the parameter icons and choose the icons I did there. The first 2 make the red dot, the next 2 make the green dot, the next 2 make the blue dot, and the very last one to be the tick cross for logic. Right, when you've finished all that, you just click on finish and it will create a My Blocks for you. Okay, one last thing left to do with our My Blocks is we have to hook up all the input parameters and the one output parameter we have. So the input parameters, there's 6 of them: the red min, the red max, the green min, the green max, the blue min, the blue max, and we need to hook those into each one of the range statements. So the red min goes to the minimum red in the first range statement, the red max to the maximum red in the first one, and we follow through the same with the green and with the blue. Then right at the end, we need to hook one wire out of the true or false of the last logic operator into the output of the block. Alright, let's write a program to use that block we had. I've just written this nice little one here, and basically it's going to detect if it sees that purple ribbon. If it sees that purple ribbon, it will turn the LED to green, and anytime it doesn't see it, it's going to turn it to red. So we're just going to pull out that custom block that we made, and we're going to have to set the range values on it to be just either side of the range values we got at the beginning when we were reading what values the sensor puts out when it's over. So we got 95, 22, 57. So the first ones I've set to 80 and 110, a little bit either side of 95. Then the second ones I've set to 10 and 40, which is a bit either side of 22. And then the last ones I've set for 40 to 80, which is a little bit either side of 57. Then I've just simply put a switch in there, set the switch to logic, pulled a wire out of the output of our block into the switch. On the top side for positive, I've just put in an LED and turned it to green. And on the negative side, I've put a little LED in and turned it to red. Okay, let's see him in action now. So at the moment he's on red because he's not detecting purple. We can put him over on the black and on the green. He doesn't detect anything. The second he goes over to purple, he turns green. Come off, he turns white. Put him on, he turns green. So you can see now we've written a program in order to detect purple. Now what happens is we can detect any colour we like. We just need to run our program that writes what the three values are to the screen, put it over it, read the three values, put those three values a little bit above or a little bit and a little bit below into an in-range statement, and away we go. Do be aware different sensors will have different calibration and put out different numbers. So the in-range for one particular sensor, if you change to another sensor, you'll have to again read the value of that sensor. It won't be the same.